This informative step-by-step video will demonstrate how to set up, deploy, and operate a drop camera, as well as how to follow post-deployment protocols. First up, the system's design. Drop cameras are simple, frame-deployed systems of various configurations that are designed to take photographic still images or videos of the seafloor. These tools are non-destructive and can go to beyond scuba depths, making them ideal for quantifying macrobenthic assemblages along a range of gradients. Different designs are available for operations off of both small and larger research vessels. In this training video, we will be covering the specifics of how to set up and operate a light-duty type drop camera off a small boat for coastal research. It's a simple, locally built construction consisting of a stainless steel frame with a downward-facing GoPro camera that sits inside a customized pressure housing. The pressure housing is depth-tested to 320 meters. The drop camera has a pair of rechargeable battery-powered strobe lights mounted on either side. These are dive torches that have a depth rating of 100 meters. It also has dive lights that go to 300 meters. The height of the frame is about 85 centimeters and the square foot is 60 by 60 centimeters. This makes up the photo quadrant. The frame is painted black or wrapped with black tape so that light does not reflect from the stainless steel. The whole system weighs about 63 kilograms and is deployed from the boat using a capstan winch. Extra weights are added to make deployment easier, particularly in regions with strong subsurface currents. It allows for the attachment of a wing or rudder, which is sometimes useful in keeping the camera upright as it moves through the water column. Setting up the pressure housing and GoPro. Remove the camera's pressure housing from the frame. Make sure that the O-ring seal of the pressure housing is clean and lubricated with a small amount of silicone grease to prevent leaks and minimize the amount of moisture buildup. Be careful when removing the O-ring, ensuring not to damage it. Using a piece of cloth or roller towel, wipe the front lens of the GoPro to remove any residual dirt or dust. Label each SD card with a number and make a note of the number of the SD card that's inserted into the GoPro. In this way, if the SD card is changed during operations, you can keep track of where your data has been stored. Check that there is sufficient battery life by looking at the bars and that there is an empty or formatted SD card inserted into the GoPro. It's very important that you make sure that the GoPro's internal date and time settings are correct. Without the correct time-date stamp on image files, it will be difficult to relate images to other metadata, such as GPS coordinates that are time-stamped by a GPS device or boat's navigation system. Set the GoPro to the desired recording settings. You do this by navigating to multi-shot, setting it to your desired settings, for example, every second, and pressing on. A red light will flicker to show that it is taking pictures. We end up with many pictures that we have to choose the best one from. Note that this rate of image capture can be reduced to, say, 1 image every 5 seconds if too many images are being recorded for the intended purpose. Now that the GoPro is ready, slot it into the lid of the pressure housing, making sure it's oriented correctly in relation to the molded insert or required field of view. Finding the best field of view can be established prior to at-sea use. To avoid moisture buildup inside the pressure housing, fill pantyhose with some silica gel or crystals, place it over the GoPro and secure it with an elastic band. Place the GoPro back inside the pressure housing. Line the lid up with the small locator pin that sticks out of the rim of the main housing to ensure correct alignment. Secure the 2 closing latches of the pressure housing with shackles, ensuring that the housing remains closed in instances where deployments can be rough or knocked against submerged rocks. Setting up the underwater torches. Underwater torches are required especially when deploying at deeper depths to ensure quality and accurate color in GoPro images, as the GoPro does not work well in low light conditions. Lubricate the O-rings of the torch housings to ensure a proper seal and avoid moisture buildup inside. Make sure to carefully remove the O-rings, ensuring not to damage them. Check that the batteries are fully charged. The torches are held by clamps on either side of the drop frame. The clamps are not as robust as the frame itself, so they can be easily knocked off. To further secure the torches, attach them via a chain to the frame. Setting up the temperature logger. Using a cable tie, attach the temperature logger to the frame. This may reveal where the temperature is an environmental variable influencing the distribution and abundance of the benthic communities we study. Make sure to preset the logger to record temperature every second. Using a weak link. If sampling rocky habitats, a weak link type attachment can be used. The end of the deployment rope has a stainless steel thimble spliced into it. This thimble is connected to the drop camera frame in two ways, directly connected to the crown via a weak link. This weak link is a heavy-duty cable tie capable of breaking under tension greater than the standard tension required to lift and deploy the drop camera. A second connection is made using a rated shackle and chain. The end of this chain is attached to a second shackle, which is mounted to the bottom of the drop camera frame. This ensures that if the camera frame becomes snagged between rocks, the weaker attachment point at the crown of the drop camera frame will break due to excess tension, and the frame will be retrieved via the second attachment point, being the chain connected to the bottom of the frame. Pulling the drop camera up from the bottom of the frame should dislodge it in the event of it getting stuck, thus increasing the likelihood of recovery. Conducting a risk assessment and writing up a checklist. Besides the weak link, we also consider sea and weather conditions when planning our field trips. To operate the drop camera successfully, the wind and swells have to be low, generally less than 10 knots of wind and a swell less than 1 meter, but be guided by your knowledgeable skipper. There should also be no strong undercurrents. A checklist is used to make sure that we have all that is required. For example, a spare GoPro if you have one, spare labeled micro SD cards and a container to place the used SD cards into. This ensures that you do not erase the data by accidentally inserting a used SD card into the GoPro. Fully charged GoPro batteries and torch batteries, as well as a container to place the used batteries into. This saves time in the field, preventing you from placing used batteries into your equipment. Silicone grease, roller towel, silica gel crystals, cable ties, a toolbox with spare shackles of various sizes, spanners and an Allen and Hex key, a medical aid kit in case of injury, gloves for the winch operator, data sheets and stationery, research or other relevant permits for the area you are targeting, life jackets, warm field gear, non-slip shoes and rations. Next up, at-sea deployment. For this section, please note that sample design is dependent on the research objective. Our sample design allows for the long-term monitoring of benthic reef communities at a selected site. It is a grid system placed over a large stretch of granite reef with pre-selected coordinate points or stations at varying depths. We randomly sample a number of stations within each depth bin by replicating the number of drops in each station. This increases sampling effort, like the number of usable images, and ensures we have a good representation of the benthos. The species accumulation with sampling effort should always be checked for your own region or habitat type, as some areas will require a greater sampling effort to reach a statistically acceptable approximation of the species richness of the benthic community. The camera is deployed using an arm-like davit and electric capstan winch to lift and swing the drop camera over the side of the boat and to raise and lower it as needed during deployment. Let's move on to the pre-deployment checks. These are done just before the camera is deployed. Get the datasheet ready and necessary information recorded, like the number of the SD card. Check if the GoPro is on. There should be a blinking red light. Turn the dive torches on. Attach a buoy to the rope in case you have to leave the camera and retrieve it later. Double-check the connection of the thimble from the deployment rope to the camera frame. Next up, operation. Ideally, this requires a team of 4, a skipper, winch operator, deckhand, and scribe to perform the following procedures. A rubber mat is laid over the side of the boat to protect the pontoon from being damaged or punctured. During deployment, the rope should be kept in a constant vertical up or down position and slight tension maintained. When the camera lands on the seafloor, slack in the deployment rope will be noted, and a small amount of excess rope is paid out so that the camera can settle. Too much slack is a safety concern for the skipper, who should ensure that the deployment rope is not in danger of getting caught in the propellers of the vessel. Once the camera lands, the bottom time is recorded and the camera left to record the images. How long the camera is left at the bottom depends on the substrate you are working on. If soft substrate, as opposed to hard, a longer bottom time, 30 to 60 seconds for example, allows for the sediment to settle. Between replica drops, the camera is lifted approximately 1 to 2 meters off the bottom, while the skipper or currents move the vessel whilst staying within the general coordinate of the station, and then it is dropped again and the process continues until the desired number of replica drops has been reached. The drop camera should be brought up to the surface when moving between stations. Lastly, we move on to post-deployment protocols. Rinse all the equipment with fresh water. Wipe down the inside of the pressure housing with paper towel to absorb any potential moisture buildup, and make sure to clean and lubricate the O-rings. Soak the torches and lubricate the O-rings once again. Recharge used GoPro batteries to ensure they're ready for the next trip. Download the data from the SD cards using an adapter and store it on external hard drives until the images are processed and stored in a data repository system. Working with drop cameras in this way provides a simple, relatively low-cost and reliable means of sampling benthic habitats for a wide array of monitoring and research purposes.